Hello everyone. Hope you enjoyed our last panel session on 5G. Now coming to the next expert talk. Compute requirements have skyrocketed over the past few years, resulting in increasing the heat densities in servers exponentially. These concentrated heat loads need a modern cooling technology that is efficient, reliable, and scalable. Well, in this context, this session would show a wider perspective on how the new age liquid cooling technology would be the difference maker in the future of cooling. It is our pleasure to welcome Mr. Nigel Gore, Senior Manager Offering Management Vertiv. A brief introduction of Nigel. Nigel has 20 years experience in IT hardware product and strategy development. His focus is in the growing demand for applications like artificial intelligence, scientific computing, and autonomous systems, which are driving the need for higher density compute architectures requiring advanced cooling solutions. Nigel holds an MBA in digital technology from University of Newcastle in Australia, and he and his family reside in UK. Over to you, Mr. Gore.
Thank you very much for that warm welcome and good day to everyone. I'm going to be describing and navigating through trends and technologies in liquid cooling today. At Birdiv, we play a key role in the foundation of the internet and digital infrastructure, keeping communication systems and data centers up and running by providing power and thermal management solutions and services, supporting exponential growth for co-location customers and hyperscale and edge computing. Uniquely, Vertiv sits at the center of two major forces: the world's ever-growing appetite for data and the need for increased sustainability measures. Our mission is to meet today's accelerating demand for data through responsible business, environmental and social practices, scaling our industries while positively impacting our people and reducing our impact on the planet. Birdiv is committed to working with our customers in solving the complex challenges related to critical digital infrastructure. And we're positioned today to help our customers drastically reduce their environmental impact. And we're innovating to lead in a more sustainable, as a more sustainable provider. When we look at the advances in computing technology today, we can see the nexus between high density and energy efficiency. We are seeing an unprecedented demand for power and performance. This is being evident through a number of new technologies. Essentially, our IT devices are getting hotter. These hotter chips are driving heat densities and driving thermal challenges for our data centers. This, combined with the need for a latency reduction due to an increased volume of data and the velocity of data as more devices become online and applications grow incrementally in terms of digital adoption. We're seeing this combined with the increased focus on sustainability and a focus on energy efficiency. So we need to balance and provide that balance between artificial intelligence, machine learning, high performance compute, and the hardware that needs to drive these exciting new application sets supporting automation. We can look around and see many applications and many industries that are benefiting from the digital economy. Finance, for example. Now, from the comfort of your home, you can navigate through your finances more easier and more quickly than ever before. You can take care of insurance, you can take care of transactions. In the back end, banking infrastructure is changing. Finance is automating, fraud detection is improving, and all over they're embracing artificial intelligence and accelerating it to provide these services. But it's not just there, it's in healthcare. We're seeing cities become smarter. Devices are becoming interconnected. The Internet of Things is now commonplace. And in media entertainment, we are seeing riveting, new, exciting, and thrilling scenes, all displayed through animation and in real life. If we move through and look at what the implications are for all those applications for the data center, we can see a number of challenges that are facing the data center. Managing airflow to keep the devices cool, where dynamic loads are changing and creating hotspots within the data center. Reduced inlet temperatures for high-density compute for these energy-hungry hot chips that we are seeing in their server devices. IT equipment is becoming denser as we see the latency need and the communication speeds increase. And the return temperatures, the exiting air coming out of the rack that is bypassing these hot devices, is increasing. So the hot aisle is getting hotter. This, combined with the managing efficiencies around energy and sustainability goals, is a challenge for the data center. So where to look for solutions that can support this? The first is the key to the strategy is to deploy cooling in close proximity to the heat source. Airflow management, containment, and in-row and in-rack solutions allow for cooling to get closer to the source of the heat. And new and exciting technologies such as direct-to-chip liquid cooling using cold plates or immersion cooling is becoming a mainstream offering. And we're seeing increased offerings coming in from the industry, including our server OEM manufacturers and large vendors such as Intel, who are looking in terms of delivering these solutions and making sure the infrastructure is there to support. So as an industry, throughout India, we are starting to see these technologies being adopted in exciting new ways. And I'm also going to share with you a roadmap of how this can scale. So let's just take a look at the market drivers and growth. We've already seen and discussed the hot chips, the CPU and GPU server components, the increasing power and demand that these devices are taking. We've just briefly discussed the low latency demand and interdependency of the components to be able to communicate faster and increase these volumes of data. We also discussed and mentioned the environmental efficiencies, the reduced power consumptions, and the need to deploy IT devices and digital devices to support the expansion of the digital economy in new environments, getting it closer to the user, which means we're moving beyond the data center and into uncontrolled environments such as the edge. This is seeing an unprecedented growth and adoption of liquid cooling. There are a number of technology devices that you can look at to be able to support it. But no matter which way you look at it, liquid cooling is growing, and we'll start to see it increasing between 16 to 28% over the next 5 years, compound. So it's growing, and it's growing fast. There are a number of technologies that one can consider, and it needs to be supported by your server OEMs and ensure that you have the technology to support your data center applications. And quite interesting is the recent announcement by Intel to support and focus on immersion cooling adoption. And I guess we're going to be seeing more and exciting news coming from the industry in the coming months. Navigating through the technology available for liquid cooling, it's important to understand the variation between indirect liquid cooling and direct liquid cooling. Indirect liquid cooling is where we're not taking the liquid directly to the IT. We're allowing for an interface between that, typically a rear door. And the technologies available include single phase and two phase. By two phase, I mean that the liquid or the fluid that is coming into contact with the heat load is changing phase. Typically, this is done by a low boiling fluid. It typically boils at about 49 degrees to 50 degrees C, way below the temperatures of the hot devices. And through that phase change, the cooling process is benefited. And then direct liquid cooling. And this is where we're looking at directly taking liquids into the server. You can meet and make the high heat components with a cold plate, again, with a single phase fluid or a two phase fluid. And then we have immersion, where you envelop the entire server in a liquid, either single phase or two phase. And to best illustrate immersion cooling, I think this video clip does a good way of visualizing the implications of immersion cooling. As we study this video clip, we observe a number of let's say, handling as well as technology benefits. In terms of handling, we recognize that the immersion tank needs to envelop the entire server. As such, we'll need human assist to remove the server from the immersion tank. So the use of a lifting mechanism is one of the first deployments that is considered when you're deploying immersion cooling. The second is when you see the server being removed from the tank, you notice how the oil, the liquid, the fluid is touching every single component within the server. That's the main components, the high heat components such as the CPU, the memory, the hard drive, but even the smaller components, the ICs, the voltage regulators, all the small components within the server mainboard. This is one of the best value propositions that immersion cooling offers because it's able to cover the entire server system. So you get 100% heat to liquid. Now, the ability to move and transport that heat when you have it in liquid means that it's opportunity to transport it more effectively, more efficiently. You can raise the temperatures within the data center, and you can repurpose that heat when you get it to a high enough temperature. If we consider how to adopt and prepare the data center for these new technologies, we need a roadmap to be able to follow for effective design, building up and adjusting the data center to be able to deploy and maintain liquid cooling. The first is to consider the design goals. Understand what are the key metrics that the data center needs to achieve for its energy use effectiveness. Is there water use effectiveness goals and designs that need to have? Is the environment that it's going to be deployed in, the climate, going to support the water demands that the data center requires for the cooling, as well as the financial or economics of the design, such as the total cost of ownership. And these will all feature in terms of the selection of the technology that can be chosen for liquid cooling, whether you're going to use a rear door, whether you're going to use direct-to-chip or immersion cooling. Next, we need to think about the design of the infrastructure that's going to support liquid cooling as the deployments will be adopted. And that means we need infrastructure to support the effective transport of liquids throughout the data center, from the external heat rejection through to the facility, all the way through the tech space. We need to consider how we will effectively transport that liquid. That includes the choice of the liquid, as well as the volume and the design of the internal pipeworks to be able to support that. It essentially comes down to effective plumbing. Ease of integration needs to be considered, how to ensure that you can install, commission, and operate the devices with ease. There are going to be some changes as the new technology starts to become mainstream. This includes the operational handling of the larger immersion tanks, dealing with liquids, dealing with heavier racks where you have direct-to-chip included in the servers. There are a number of benefits in the economics, and we need to think hard how to effectively optimize our deployment strategies for these new technologies to be adopted with ease. And then new training that needs to occur. We need to establish best practices. This is a nascent technology. It is not at the scale and volume of understanding that we have with air cooling today. So there is a job that we have as an industry leader to ensure that we can establish the best practices to be able to adopt liquid cooling. We need to do this to learning, and we need to share. And we're able to make sure we can provide services that allow and enable installation and commissioning and maintenance of these technologies with ease. And we want to make sure that we can do this whether we're in Bangalore, in India, New Delhi, or whether we're in Mumbai. We need to be able to deploy this globally. We need to expand it beyond just Asia into Europe, Middle East, Africa, as well as to North America. And I think that we're going to see an exciting new array of deployments for liquid cooling as this technology gets traction. So at Vertiv, we're seeing that you need to cover a complete liquid cooling ecosystem. We need to look at our heat rejection devices to ensure that they can support liquid cooling. We need to distribute and have infrastructure to support the distribution of liquids within the data center. We're giving specific focus to the designing of infrastructure to be effective within these new demands for the data center. Certain devices will need chilled water. Can we deliver that precisely and effectively in terms of flow rate, pressure drop, as well as increased demand for heat effectiveness for these devices. So whether we're deploying a door or a direct-to-chip device or an immersion cooling system, we have the flexibility to deliver the necessary water rate, water type, as well as flow and pressure for those devices. And then in terms of immersion racks, are they optimized and designed for the data center? Do they have the capabilities to support the IT that is optimized for immersion? And are they designed for a footprint that can be beneficial to the data center to allow for the service and operation teams to operate them effectively? So we have some very exciting times ahead of us in terms of deploying liquid cooling, as well as managing and benefiting from all these new exciting applications. Thank you very much. That brings an end to my presentation today. Thank you.
Thank you once again, Nigel, for your excellent stimulating speech on immersion liquid cooling of ecosystem. Thank you.
Thank you very much. Good to speak to everyone today.
Another exciting set of panel discussions are now lined up for you all. Stay tuned.